everyone. Hope all of you are doing well. Today we are going to discuss the plus 2 physics practicals. Now we will verify the series and parallel combinations of resistances using meter bridge. Here the aim of the experiment is to verify the laws of combination of resistances, that is series and parallel, using meter bridge. Here when for your practical examination, the question itself will be the aim. So you can copy the question as the aim of the experiment. Now the apparatus required is a meter bridge, Lagrange cell, galvanometer, a resistance box, jockey, 2 resistance wires, set square, sandpaper and connecting wires. After writing the aim and apparatus, we have to write down the theory or principle. So that we have to write only the necessary theory here. And in our question, only the series and parallel combination of resistances are asked. So the equation also should be for both series and parallel only. Suppose we are getting that x1 and x2 are the resistances of the given wires. Then in the case of series connection, we have the effective resistance as xs is equal to x1 plus x2. And we have to mention the symbols also. Here x1 and x2 are the unknown resistances. Okay. And for the parallel connection, the effective resistance will be xp is equal to x1 x2 divided by x1 plus x2. Also, the value of x1 and x2 we can find out independently by using the equation x is equal to R into L by 100 minus L. Here R is the resistance from the resistance box and L is the balancing length. This much only we have to mention here. Now we can start the experiment. Here there will be 2 unknown resistances given to you. So first of all we have to connect them separately and find the resistance of both the wires. After that only we will connect them in series and then in parallel. Now we can make the connections with the first wire in order to find the unknown resistance. Here we can see that in the meter bridge there are 2 gaps, that is R and L are here. And at the center B there is a connection, and on the opposite side we can see a meter scale, and at the end of A and C. Okay, now suppose we start the connections from the cell. So from the positive of the cell we have to connect to the end A, and from the negative we have to connect to key, and for key there is no polarity, so no need to look into positive or negative. We can connect to one end, and from the other end of the key we have to connect to end C. Now we will get a closed circuit here. Okay, and now we have to connect in these 2 gaps. In the first gap we can connect a non-resistance. Non-resistance will be a resistance box having very small values, only 1 to 5, like that we have to remove from the resistance box. And the unknown resistance that will be given to you, that metallic wire we will connect in the end, second end, because here instead of that R. Okay. And from the center we can see a connection that from B that we will connect to a galvanometer, and from galvanometer we will connect to jockey, that is represented as capital D. Now our connections are over. Now we have to make sure that our connections are correct. Okay, for that first of all we will close the key, and then here we can see a metallic wire connected between end A and C, that will be on the top of the meter scale. And first of all we will take the jockey and we have to just touch the jockey in end A. Then we will get a deflection in one side of the galvanometer. Okay, so note that deflection, and after this we will keep the jockey on the other side, that means at the end C. Then we have to get the deflection in the opposite side of the galvanometer. Suppose we are getting the opposite side deflection in the galvanometer, our connections are correct. Otherwise, suppose we are getting in both sides the same deflection, that means the deflection is in the same side, there will be errors in your connection. And if you are getting any problems like that, you make sure that all the keys are tight, or if any air gap will be formed, because if your connections are not tight, there is a possibility of forming air gap, so that you have to remove the connections and make it tight. Then you will get opposite side deflection. Then only we can start the experiment. If the connections are correct, we can start the experiment. For that, first of all, we have to remove a very small resistance from the resistance box, say 1 ohm, 2 ohm like that. and the jockey is moved along the wire till the galvanometer shows a zero deflection, and the jockey is only a sliding contact, so please don't press it for a long time, so that will affect our galvanometer. You have to gently move through the wire, and whenever we are getting zero deflection, there you can stop and take the reading. So here we can see that the distance between that A and the jockey, here AD, that will be the balancing length L. Okay, so that length we can measure, or directly we can measure from the meter scale itself. The reading will be given there from one side, so that will be the balancing length L, and now we can calculate the rest of the reading. So that R value we have to note, and then the 100 minus L value will be 100 minus that L. That suppose we are getting 40 as the balancing length, then the 100 minus L will be 100 minus 40. And always the balancing length should be almost at the center of the meter bridge. That means it is better to get the reading of balancing length between 40 and 60. And after getting the first reading, we will remove one more resistance. That means we will increase the value of resistances for minimum 3 readings, and we will find the balancing length in the similar way. Now we have to write down the readings in our tabular column, and we will find the unknown resistance by using the equation X is equal to R into L by 100 minus L. Now that we know R, that suppose we are taking 1 ohm, that will be the value of R, and L that balancing length, and 100 minus L. By using this we will find the unknown resistance. After getting the value of x1, we will replace the first wire with the second. Then we will calculate x2 by repeating the similar procedure. Now we have the values of x1 and x2. Now we have to find the resistance in series combination. For that we have to remove the wire, and we will take both the wires together, and we have to connect in end to end. That means in series we have to connect the wires. All the other connections are similar to the first experiment. Okay, now we will do the similar procedure. That means the resistance we will remove, and we will continue the experiment for different values of resistance, and then we will tabulate the values in order to get the effective value of resistance in series combination. Now we have to connect the wires in parallel as shown in the diagram. Here both the ends of the wires we will connect together, and we will do the experiment for different values of R. Then we will get the effective resistance XP. Okay, then after this we will calculate the theoretical value, and then we can tabulate the readings. Here we can see the tabular column. Here R is the non-resistance that we remove from the resistance box. That value we have to enter here. Then L is the balancing length that we are getting, and 100 minus L we can write here. Then we can calculate X as R into L by 100 minus L. And the mean value we can calculate, and in the similar way we will repeat it for X2 and series and parallel connections. Okay, so we will get the values of unknown resistance. In the calculation part, we have to write down the theoretical value and experimental value for both series and parallel connections. In the case of series connection, the theoretical value will be x1 plus x2, right? So we will add these two in order to get the theoretical value, and the experimental value we will write down as we are getting in the series combination, and both the values should be matching. And the theoretical value of parallel connection can be calculated by using x1 x2 divided by x1 plus x2, and that value we will write down here, and the experimental value that we are getting in the from the experiment, so that both values also should be matching. Then we can wind up our experiment. In the result section, we have to write down within the limits of experimental error, experimental and theoretical values of RS and RP are same. And here the RS is equal to R1 plus R2 is verified, and RP is equal to 1 by R1 plus 1 by R2 is also verified. And below that we can write down the values, that is XS is equal to x1 plus x2, and xp is equal to x1 x2 divided by x1 plus x2. So that values also we have to mention here. Hope it is clear to you. Now we can conclude here. If you like my videos, please like, share and subscribe. Thanks for watching.